Okay, we're in the fourth video about AI factor at portfolio 1, 2, 3, and in this video we're going to build a predictor and look at the feature importance. So in the last video we already built those predictors here. Again, let's go to the results. Let's say we want to build a predictor here. You say create predictor, and let's say we say 10 here, and we are going to build a predictor to 2019, and we say submit. And then it will pop up here and you basically can start. You choose your worker and then you say start. Okay, this you know, I did before, nothing to do with the video. So this is running now, and let's now look at some functionality. So we can go to predict and you can say, all right, we're going to take extra trees, ton of features, and you say predict. And here we go. Right, so this is compared to ranking, basically, this is the highest ranked stock right now. Another thing is you can look at the performance. So let's go to ton of features here as well. And what you see now is what the machine learning is basically doing with all the data and with all the assumptions. So what is it doing? It looks at the target, it looks at rank, all the assumptions, target normalization state. This is all the data, right? And on the prediction importance, you basically see that it's identifying sector dividend growth as the highest, so the most important feature. And this only works with extra trees, random forest, LightGBM, XGBoost, and linear. On the other machine learnings, that's not possible. But in here, you basically see which features are the most important, right? Which features are the most important for the machine learning that you picked here. This would be extra trees, that would be ton of features, extra tree 3, ton of features. And it's basically showing the feature importance here. So now the question is, why don't we just take all those features here and put it into a traditional ranking system? And I did that, not with 365 features, but let's just say with 15 or something like that. And the results were similar, but they were not the same. And the reason for this is, let's just go in here. That's a question I gave to ChatGPT, basically. So that's a great way to learn. So why a factor system can do what traditional ranking can. So first of all, factor interactions. So yes, you will see this is the most important, but the factor interactions we will not really see, right? So it learns combination like value momentum equals alpha, but only when volatility is low. The other thing are nonlinear thresholds. So AI captures conditions like only matters if depth below 50% and growth over 50. So rank-based models miss those thresholds, or it's harder to build that. The composited signals are AI network forms new synthetic factors, so like quality and price stability plus EPS acceleration, without basically needing to handcraft them, right? Then adaptive regime awareness. AI learns what works in different environments. It adapts dynamically across bull, bear, inflationary or recessionary periods. Also very hard to do with traditional ranking systems. So if you look at that, it will show you the most important features, but it's not comparable with traditional ranking systems. And again, I took all those, I took this thing here, I downloaded it, right? And then I put some of the factors in traditional ranking systems and I took that as a weighting basically. And yes, it comes close, but it's not as good as AI, as the feature importance and what it's doing basically within the ranking system. All right, in the next video, we're going to build a screen basically with such a predictor here, right? Yeah, looking forward and see you there.